Okay, hi again, everybody. For the second half of my little chunk of time, I will tell you give you just a few slides telling you about the work and the interests and the people who are in my lab at McGill University, in my lab, which we call the Computational Landscape Ecology Lab. A lot of the work that we do flows from this algorithm for Bayesian updating of land cover using taking in any data, which you can see there on the left of those three panels, turning it into a classification, and basically that is what bulk sees. It sees these classifications and then turns it into interprets it in order to give you the image that's shown there on the right. As a result, we're able to be independent of any platform. That middle panel can be produced in anyway. And so as a result, the rightmost panel, which is bulk's interpretation, doesn't really know where the data comes from or isn't worried about where the data comes from. And so as a result, as you can see here, we have information in this study, in this little series from all of the Landsats, CBERS, the Chinese-Brazilian satellite, Landsat 8 and as well Landsat 9 and Sentinel-2 are in the mix, as you'll see here in the next set of slides. As a result, what we're able to do is to deal quite well, I think, with clouds and haze and messy images, and it's quite good for that. One of the flavors of bulk that we have been rolling out in the last year is called bulk D, which stands for the deviation from our expectation. And you can see shown there on the left is a typical image from 2021. On the right is a typical image from 2022, or an image from late in the summer season of 2022 in Canada. And you can see down in the bottom left, the part that is shown in red is the area that we would consider, that bulk would consider very likely to have had a drop of a value, in this case of NBR, which indicates change. Interestingly, you can also see these blue values where we say that there is likely an increase in that value. We can then interpret that in whatever way we want, that mixture of red and red type colors, green and greenish colors, and blue colors, in whatever way we want, and in this case on the right, produce a map of forest loss in that time. The resolution is at 10 meters because that's what we get with the mixing together in bulk the Sentinel and Landsat data. So here, just as an example, shows a particular fire, a well-known fire in Quebec from a couple of years ago, 2 or 3 years ago, the published perimeter on the top, and the burned and unburned final border in the bottom. You might wonder, it looks like a bear to me. You might wonder at the stomach of the bear why it's considered still green and unlikely to have burned. And the reason is it's actually a large reservoir down the middle of where this fire was. So I show you that picture so that I can show you this, which is this intra-year estimation of change. And what this shows is the estimation. This is pretty old now. We've got, I think, could do a better job of this map if we were to go and revisit this work. But it produces for us the date of the detected change. And so we have a date of when it was first suspected and a date of when it was confirmed. And for that, we use this vector of probabilities, which is what bulk is actually keeping track of as it runs. So what we're able to do in this case and in any case is track within the year our estimate of when something changed. One other really neat thing that the same code can do is to refine a coarser classification. Here you can see this is the globe cover classification, the old globe cover classification, 300 meters on a side, being fed information from Landsat, and it then turns that 300-meter classification in light of the new evidence and steers the data toward a 30-meter representation of the same area. What is being used here is unsupervised classifications. That's what the letter U stands for. And I don't normally show this slide, but I think it actually could perhaps be relevant for refining an existing land cover map using the finer scale planet data that we have. So the same analogy, I think, would work, where we have a coarse classification on the top, can interpret it in light of new evidence, and see if we can come up with a slightly finer scale classification shown there on the bottom. So I'll just finish now by telling you about people and projects in my lab. Just for 1 minute, we'll do the fastest possible run through the people involved. Many of you probably know Africa Flores Anderson, a real star of remote sensing, who has very graciously decided to come to my lab to do a PhD and lift the quality of all of our work by a lot. She is interested in incorporating SAR into bulk, into this Bayesian framework, in order to do multi-sensor estimation in cloudy areas as well as cloud-free areas. So there would be some, some blending of Landsat and Sentinel-2, as well as Sentinel-1 and any other future SAR series that are produced. Flavie Peltier is estimating biomass growth and loss with high precision disturbance maps, the ones that you saw just a few slides ago, across all of Canada. So it's a really very, very big area, but being done quite well by Flavie. Rylan Boothman is originally a computer science student, and he works with TensorFlow to try to extract as much information as possible from old MSS data. MSS data, of course, doesn't have as good of a spectral resolution or spatial resolution. And so the idea is that by using TensorFlow and some of its sensitivity to spatial pattern, that he would be able to extract new information from there. We're almost done here, and I'll just mention a couple of other projects. Bryant Sayre, who is an amazing master's student in my lab, is looking at dynamic world and the repeat views of landscapes that we get with dynamic world in order to explore this long-standing question within landscape ecology, which is how good are landscape metrics? So the number of patches or the contagion or those types of analyses of a two-dimensional landscape classification. We previously have not had a lot of instances or repetition of those classifications. With dynamic world, we can actually produce a data set now in order to answer this longstanding question in remotes or in landscape ecology. I'm also very interested in updating harmonic regression coefficients with Kalman filtering. Just gave a little talk on some demo work of that at AGU. And also interested in starting a project thinking about accuracy assessment approaches with Bayesian stats. We've got great accuracy assessment, the unbiased work of Pontus that you all know about. And I feel like there's still a little more that we can do with that. And then finally, from a different part of my interest, we are interested in estimating how much carbon there is across the lakes of Canada, and there are a lot of lakes of Canada, about 1 million. So to finish, I'll just say again, thank you very much. That's a quick review of the work and the interest and the people within my lab. Thanks.